This meeting is being recorded.
In this last section of Chapter 14, we're going to look at catalysts. And a definition that you can use for a catalyst is that it increases the rate of the reaction by decreasing the activation energy of the reaction. So the change in a mechanistic pathway happens, and that we can see over here on this graph. We have a red line showing the amount of energy that's needed for our reactants to turn into products. So this activation energy would be needed for an uncatalyzed reaction, whereas with the catalyst added, so see we have different reactants here beyond just our hydrogen peroxide or H2O2, and our reaction pathway changes so that we have a much lower activation energy in this first step, and we actually have a second step in this reaction now, in this new mechanistic pathway. So two different activation energies, both are lower than the uncatalyzed reaction. And this is an example of what we can refer to as a homogeneous catalyst, because the reagents here and the catalyst are both in the same phase. So everything here is aqueous phase, they're in solution. And also notice that the catalyst is not consumed in the reaction. So it's returned over here on the product side, what was entered in on the reactant side. So that's good to note that catalysts are not consumed like intermediates are, but they do also appear on both sides of the reaction, similar to that of intermediates. So it's there at the start of the reaction, but again, it remains. So note the difference between catalysts and intermediates. Also, you should note down here what a heterogeneous catalyst is. So we have a metal surface here. For this type of reaction, it would either be something like platinum or nickel. And notice that that's a solid surface. And then we have these hydrogen gas and ethene gas here. And we're shown that H2 and C2H4 are adsorbed or bind to a surface here, as this definition tells us. And then a reaction occurs where the hydrogen is actually added to the molecule, and then it leaves as ethane. So these, again, are examples of having two different phases. We have gas and solid here. So one way that catalysts can speed the reaction up is holding the reactants together to help the bonds break. So that's what we see with this example of a heterogeneous catalyst here. And the last bit of information we should take note of is that a special type of catalyst, a biologic system catalyst, is an enzyme. And in this model here, we have the enzyme shown as blue here, what's referred to as the substrate, which is the substance that will react at this site here, which is referred to as the active site. So when the substrate combines with the enzyme, it enters the active site, the specific location within the enzyme where the reaction takes place. We see this transition occur, and then finally, the enzyme is not consumed, that's returned at the end, as any catalyst is, and our products are produced.